Okay, so we are continuing our lessons on 3D shapes. I know that we want to get on to the exam questions and things like that, but we do need to take the 3D shapes. Today I'm going to do cylinders, and I'm going to do cones, not prisms, because we did that yesterday. And then we'll do spheres, and then we'll be able to get into the actual exam questions then after that, all right? So we do have a purpose and we are on our way. So we're continuing with the 3D shapes. So the first one here is volume of a cylinder, okay? So we all know what a cylinder looks like, but it is important to recognize that a cylinder, on the top of it here, it has a circle. So the area of a circle comes into play here to find, what we do is we find the area of this face and then we multiply it by the h. So our formula for volume of a cylinder is pi r squared, you recognize that as volume of a circle, h. This is in page 10 of the log table, so we don't need to know it off by heart. Pi r squared h. Now the net of a cylinder is obviously a little bit more trickier, and we use the net of the cylinder if we're asked to find the CSA, which stands for the curved surface area. So if I was to draw the net of that, I would find that, first of all, at the top I would have a circle, at the bottom of it I would have a circle, same, and then within, in between the two, I would have the rectangle, okay? So that's what the net of a cylinder looks like, but there's a relationship between this, the length of this, and this here, because obviously this, if I was asking you to find the length of that, I'd be asking you to find the circumference, and the formula for circumference of a circle is pi r. And if I was to cut that, that would be the exact same as the length of this. So 2 pi r is your formula for circumference. So the curved surface area, we know how to find the area of this, which is obviously your circles, but this section here, we call this the curved surface area, okay? So I'll have to draw an arrow. So that's the curved surface area, and the formula for curved surface area is 2 pi r h. So again, that's in formula 10 of the log tables. It's in page 10 of the log tables, but that's super important. If I'm asked to paint this cylinder, okay, I would be painting this. So I need to find the area of this, which is 2 pi r h. I also need to find the area of my circles. So don't forget, your area of a circle is pi r squared. Okay, so curved surface area responds to this, but if I'm asked for the whole surface area, I have to include my pi r squares as well. With questions regarding cylinders, it is really important that we decide what type of cylinder it is. So this one, if I'm asked to find the curved surface area of this, I'm just asked to find this. If I'm just to find the area of this, that would just be the curved surface area. Here I would have the curved surface area and one circle. And then here it says the cylinder is closed, but another word that they often use in exams is it's a solid cylinder. So a solid cylinder has circles on both ends and completely closed. So for that, I'd need the curved surface area and the area of two circles. So remember, surface area is different with cylinders compared to volume. Okay, so we're going to do example 1 together here. So a cylindrical tin of paint has a radius of 14 centimeters and a height of 22 centimeters. Taking pi as 3.14, find the volume of paint of the full tin. Okay, so I'm just basically here finding the volume of a cylinder. Volume of a cylinder, we know the formula, it's in our log tables, it's pi r squared h. So in this case, sometimes they tell me to keep it in terms of pi, sometimes they say pi is 22/7, but in this case they've said pi is 3.14. So that means it's 3.14 times the radius squared, which I'm told is 14 centimeters, times 22, the height. And I am getting, for that answer, 13,539.68. This question asks me to give it in litres, so we did this yesterday in yesterday's lesson, so we know that 1,000 centimetres cubed equals 1 litre. So I'm going to divide that by 1,000 and bring in my decimal point, 1, 2, 3, and I'm getting 13.54 litres. Okay, and I've gotten the 5,4 by rounding here. The next part of this question asks me to find the area of the metal sheet needed to make the tin. So the tin is completely made of metal, so I need metal at the top, metal at the bottom, and metal all around the sides. So that is essentially a solid cylinder, and I'm asked to find the surface area of the solid cylinder. So again, I always find a net really helps me with these. So I'm going to draw my net, and I know that with this I'm going to have a circle on the bottom, a circle on the top. So what information am I told? I am told that the radius is 14 centimetres, so I know that the radius from here in is 14 centimetres. I'm also told that the height is 22 centimetres, so when I have the tin itself, its height is 22 centimetres, so that's that there. And now I have to find the area of each of those. Now I am aware that to find the area of this circle here, it's going to be pi r squared. I presume we're still taking pi as 3.14. So that's going to be pi r squared, which is 3.14 times 14 to be squared. That's going to be the exact same, pi r squared okay. But what I do need to find is I need to find the curved surface area of this bit here. Now, we need to find the length and the breadth of this, okay? We do know that the height, or the width here in this case, or the height, is 22 centimetres, but I don't know what that length is there. But I do know that this red section here has to be equal to the circumference of any of the circles. So formula for circumference is 2 pi r. I know what my r is in this circle. I know it's 14. So it's 2 times 3.14 times 14. That gives me the circumference of the circle, which has to be equal to this length here. So for this section here, down here, I'm getting 87.92. I now just need to find the area of my circles, add them together, and I'll have my full area. Okay, so for each circle here, when I do this formula here, I'm getting 615.44, and again here 615.44. So to find the complete surface area of the whole metal, I'm going to add my three numbers together. So I'm going to add this plus this plus this together. Okay, so these are my numbers so far. So the two areas of the circles is 1230.88, and remember it's length by width here of the rectangle, and I know the length is now 87.92, the width is 22, so if I multiply those together I'll get the area of the rectangle there, and my final answer then is 3165.12 is the area needed of a metal sheet in order to create this. Okay, cones is the next thing we're looking at today, alright, and the formula for finding the volume of a cone is given to you in your log tables as well, so happy days, you don't need to learn it. It uses the R, which stands for radius, and H, which stands for height, so perpendicular height here, okay, so notice the 90-degree triangle, or the 90-degree angle that's created. So formula of a cone is 1/3 pi r squared h, okay, or you could write it as pi r squared h all over 3, because remember the 1 goes on top there, and that obviously doesn't have any benefit. So either of those, and it's written in your log tables. Surface area of a cone. So if I was to paint the cone, that suddenly changes things a little bit, and you'll have a look at a notice of this animation here where they're kind of showing you that if you cut that down and you lay it out, this is what it would look like. And hopefully you're making the connection there that it does look like a sector of a circle. Okay, and then with your cone, it depends if it's a solid cone or not, but you could have the base here, which would obviously look like a circle. So normally when you cut it all out, your net of a cone will look something like this. Not really probably the best diagram. All right, so it looks something like that, and then you'll obviously have your base, which is your circle at the bottom. Now, what is the formula for surface area of a cone? Well, it's also written in your log tables. It's written on page 10, and it says the surface area of a cone, so CSA, of a cone is equal to pi or L. Now, pi we've met before, or we know is radius. L. What is this L? Well, actually, we've met it before. In the diagram that I showed you just there a few minutes ago, we have or, but we have our H, but our L is actually this here. Don't know where the 4 came from. Okay, so that's our L. Okay, now we need our L to find our curved surface area. If we are not given our L, but we're given our H and our or, we can find that using Pythagoras. Okay, so don't forget Pythagoras will work a lot with cones here. Okay, so curved surface area of a cone is going to be pi or L if it's an empty cone, but if the cone has a circle on the bottom, remember it's going to be plus pi or squared, so plus your circle. Okay, so example 2, calculate the curved surface area and the total surface area of the cone. Okay, so the curved surface area, remember that doesn't include the bottom bases or the face there. So the curved surface area would just be this section here. The total surface area includes the circle at the end. So a curved surface area of a cone, we have our formula, and it is pi or L. It says in terms of pi, which means pi is going to be in my answer. So it's pi by or, which we don't know in this case, by L, which I do know is 20, so I can rewrite that as 20. Now, so the first thing is I need to find or. So let's look in here. What have I got? Get rid of that green. Whoops. And I have a right angle triangle, okay? Right angle triangle with a length of 20, x or, we don't know it, and 16. So Pythagoras I can do here. Remember, we use a squared equals b squared plus c squared, where a is the longest side, which is always opposite the right angle. So I've got 20 squared equals 16 squared plus x squared, and we're going to finish off. Alright, so I know everybody is very familiar with this at this stage, okay? Letters to one side, numbers to the other, solve for your unknown. You should work it down. You should get x equals square root of 144, so x is equal to 12. So I'm kind of happy enough with that now. I have my 12, and so the first thing I'm going to do is find the curved surface area, which is pi by 12 by 20, which gives me 240 pi. Remember, in terms of pi means pi in my answer. And now the second thing I'm going to find is the total surface area. So that's going to be pi or L plus pi or squared. So I know the pi or L is 240 pi, plus the pi or squared is going to be pi times the radius squared, which is 12 to be squared, which is 144. So I get 240 pi plus 144 pi, which gives me a total of 384 pi. So just have a look over that. I want to make sure everything there is okay. So our learning check, if you could please submit it for me. Make sure when you're submitting that I can see if you've done it over 2 pages that it's a screenshot over 2 pages, because that for some reason I can just seem to see 1 page. And then I'm replying with the comments on if you've gone wrong on anything. So if you're not getting those, can you please let me know? But I'm also replying if you've gotten them perfectly correct. I'm giving you marks out of 100, so hopefully you are seeing those. So yeah, we've got spheres to do, and then we'll be into exam questions, and kind of, well, leading on into getting there, because that's ultimately where we want to be. Okay, hope everybody is well. I'll create the assignment where you can upload these.